Okay, so infinite limits and limits at infinity. Okay, so basically what we're going to find is we're going to have vertical asymptotes involved. Okay, so it is important and very valuable, especially for future sections, to understand vertical asymptotes. Okay, so everybody looking at this box here?
Yes.
Okay, so we have this function and we have this gnarly looking rational function. And you got a whole bunch of stuff in the bottom. Okay, so the cool thing about this is it kind of shows us different scenarios that you are going to see. Okay, we always try to simplify before anything. Okay, so is there a quantity that would cancel with the top quantity? Okay, so anything that cancels creates a hole. Okay, it leads us right into there, and we know that there is a hole at x equals 1. Okay, the value that makes that quantity 0. Okay, anything less is going to be vertical asymptotes. Okay, now there are different types of vertical asymptotes. Did you know this? Okay, we have even vertical asymptotes, and we have odd. You guys check this out. Do you see this picture?
Yeah.
Tell me about what even vertical asymptotes look like. What is happening?
They both go to the same interaction.
Yeah, so when we have even vertical asymptotes, it like sucks both sides of the function up towards it or down. It's like a volcano effect. Okay, so anything that has an even exponent, you see where I'm looking? An even exponent is going to cause that even asymptote look. Okay, so where on this function would I have even vertical asymptotes? At x equals 2. Okay, and odd, and this is the one we've seen most often in our past, is when the function literally splits apart. So one side goes up to positive infinity, and the other side goes to negative infinity. Okay, that is literally going to happen when you have an odd exponent. Okay, very simple to identify and very informative. Okay, so where are you going to see odd vertical asymptotes on this function? At what x value? 4. At 4.
Can they be in the same, like in this function, should they be in the same graph?
Yeah, so let me go ahead and show you what this function would look like, just so you can see. Okay, so I'm going to type in the actual original. So we had x minus 1 first. Okay, the bottom we had x minus 1. We had x minus 2. Okay, so we should see some kind of volcano-y thing going up there. And then we had x minus 3 for the last one, so that's going to show our 4, thank you. A split. Are you ready? I'm going to hit zoom 6 because I don't know what window I was in before. Okay, so for this function, this is not a great example. I kind of wish I would have done this in a Desmos instead because of how pixelated this is and how steep the function is. But what is happening is there's actually a horizontal asymptote as well. We will talk more about horizontal asymptotes, but this function is infinitely close here and does kind of that, what do we call that, like hourglass shape on that side. Okay, and then on the other side of this x equals 2, we have an upside down parabola. Okay, and then on the other side, we have that hourglass shape again. Okay, so kind of a strange looking function. Okay, so let's talk about infinite limits. Okay, so an infinite limit is simply limits that go to infinity or negative infinity. Okay, and we are going to say that infinity is going to be a destination as opposed to does not exist. Okay, so when we're talking about one side or the other, I want to know which side we're going to. Okay, all right, so question number 1, they give us an example of a limit coming from the right. Okay, so the very first thing we want to think about is if I plug 2 in, what happens? Okay, so I get 5 over 0. I get a number over 0, so that tells me what's happening in the graph.
Vertical asymptote.
We got a vertical asymptote. And not only do we have a vertical asymptote, what kind of vertical asymptote do we have? Is it an even function or an odd? Okay, it's odd. So I know that at 2, this function is splitting apart. So one side is going up to infinity, the other side is going to negative infinity. Okay, so if I look at questions number 1 and number 2, I can tell you one answer is going to be infinity, and the other answer is going to be negative infinity, or vice versa. Okay, so now how do I distinguish between them? Okay, I'm going to plug in a value slightly bigger. Okay, so if I'm coming in from the right, I'm just going to pick a value slightly bigger, and then I'm going to decide, is this going to a positive number or a negative number? So give me a number that's slightly bigger than 2. 2.1. So if I plug 2.1 in, okay, I'm really not too worried about the exact value. I'm just worried about if it's positive or negative.
0.
Okay, so if I simplify the top, is it going to a positive number or a negative number?
Positive.
Positive. On the bottom, is it going to be positive or negative?
Yes.
Positive. If I have a positive over a positive, can you tell me where is this function going to from the right side?
Infinity.
Positive infinity. Okay. So let me show you what it looks like if you're going to get negative infinity. Okay, so for question number 2, I'm going to plug in a value slightly less than 2. Give me a value slightly less than 2. 1.9. Okay, if I was going to plug 1.9 in, would I get a positive or a negative on the top? Positive. What would happen on the bottom? Negative. If I have a positive over a negative, where is this function going to? Negative infinity. Do we understand how to decipher between the two? Okay. Let's try another one. See if you got this. Okay, first thing I always do is I plug the function value in. If I plug in 1, what happens? You get negative 1 over 0. So I know there's a vertical asymptote, so now I have to decide, is it going to positive infinity or negative? Plug a value slightly bigger than 1 in, so what number are you going to plug in? 1.1 is good. Okay, on the top, if I simplify that, is it going to be positive or negative? Negative. What about the bottom? Positive. Anything squared is going to be positive. So where is this function going? To negative infinity. Ooh, that was a good infinity sign. Okay. All right, let's try number 5. Okay, this one is a little different. It's not coming from the left or from the right, so we were just thinking about both sides. Okay, so if I plug 2 in, what's going to happen here? So if I get a 0 over 0 scenario, that means the limit does exist. It just happens to be a hole, so what do I got to do? Factor. Okay, so be forewarned. You are going to see all kinds of limits. So anything that we've already learned, you will see that in your assignment. So don't assume every answer is infinity or negative infinity. It will not be. Okay, so after I fact it, what cancels? So now I have x plus 2 as my function. If I plug in 2 plus 2, my limit value is
4.
4. Okay. 4. All right, that's pretty easy, right? Nailed. You guys are ready for the AP Calc test? Well, no, I don't. I'm afraid it wouldn't be good. All right. So the next part of this is learning to find limits at infinity. So you're going to see the notation, the limit as x approaches infinity. Okay, and that is where we care about horizontal asymptotes. Okay, so we talked about how to find horizontal asymptotes last time. I'm going to pull this off to the side because I have tricks that I have used, and those are the tricks that I want you to use because they're easy. Okay, horizontal asymptotes. How do you find horizontal asymptotes? There's 3 cases. Do you remember the 3 cases and what we're looking at? Case number 1. So what we're looking at is the exponents and comparing the exponent on the top compared to the one on the bottom. Okay, so for example, if I had 3x to the third plus 2x plus 1 over, I don't know, 5x to the fifth plus 2, okay, I'm simply looking at the biggest exponent on the top and the biggest one on the bottom, so I'm looking at these first 2 terms. So which one has the biggest exponent? The one on the bottom. So if the exponent is bigger on the bottom, does anybody remember where the horizontal asymptote, if it's bigger on the bottom, is?
Bigger on the bottom is 1.
It will always be at 0. Okay, always. That is an unchanging thing. Okay, the second case is, let's just say we switch these two and say we have 5x to the fifth plus 2 over 3x to the third plus 2x plus 1 on the bottom, okay, where the exponent is bigger on the top. Oops, bigger on top. Do you remember what bigger on top implies? It implies a slant asymptote. Very good. So slant asymptote means that you're going to infinity or to negative infinity. Okay, so that's one you're going to have to test. Okay, and so our last case is what?
They're the same.
When they're the same. So for example, if I have 3x to the third plus 2x plus 1 over 5x to the third plus 2. So exponents are the same. Okay, that is specific to the function. So for our example, where would I have my horizontal asymptote? 3/5, very good. Okay, so that simply comes from the coefficients that are in front of our 2 biggest exponents. Okay, so you guys remember this a little bit?
Indeed.
Okay, so that's what we're going to be looking at. We're looking at as x goes to infinity and as x goes to negative infinity. We're talking about end behavior for the most part here. Okay. All right, so the first view is going to just be, let's see if you can find, oh, man, did I go too fast? Sorry.
5 pence.
Okay, whatever you want to do. All right, so questions 6 through 8 is simply, first let's just find what the horizontal asymptote is. Okay, so for number 6, is the exponent bigger on top, is it bigger on bottom, or is it the same? Same. So if it's the same, where is my horizontal asymptote? 5 over 10, right? 5 over 10, which can be simplified to 1/2. Okay, so we have a horizontal asymptote at 1/2.
Now the next one's bigger on the bottom, so what do you do?
Okay, what do you do? Bigger on bottom. That's our first case. It is always y equals 0. Oh, good. Do you know number 8, when it's bigger on top?
Yeah.
What?
What happens?
Nope.
Just kidding.
Bigger on top.
Slant.
Figure out. Pants.
Slant. Did you not write it all down? So there's no horizontal asymptote here, but there is a slant. Okay, so bigger on top. Make sure you write those down, Gary. If they asked us to find the equation of the slant asymptote, you would have to do it by doing long division. And I don't think they're going to make you do that. It is gross. That might be helpful when we're actually drawing equations. It's not super fun. It's a lot of work. Okay. So question number 9. So now we're actually getting into the limit spot. Okay, so the nice thing about limits that go to infinity, you are simply looking for horizontal asymptotes, or the end behaviors of things. So if I have horizontal asymptotes, the horizontal asymptotes are going to be what the limits are going to. Okay? If I have a parabola, what is my limit as x approaches infinity? Infinity. It's going up. So I have to consider they might not always be rational. There might not always be horizontal asymptotes involved. Okay? So I have to consider the end behavior of my function. Okay, so for question number 9, we have a rational equation. Do I have a horizontal asymptote? Okay, is it bigger on top or is it bigger on bottom? It's the same, so my horizontal asymptote is at 1/2. So my limit value as x approaches infinity is 1/2. Okay, it is exactly the same as where that asymptote exists. Okay, number 10. Do I have a horizontal asymptote?
No. Oh. Yes.
It is bigger on the bottom. The horizontal asymptote is at 0. So what is my limit as x approaches negative infinity? 0.
12.
All right, guys. Come on. We're almost done. Okay, number 11. Do I have a horizontal asymptote? Well, it's not horizontal, it's a slant, right? It's a bigger on top. So it's either going to be a slant like this or a slant like this. Okay, so that means that this function is either going up to positive infinity or negative infinity. So how can I figure out which one it's going to?
You just look for the values which is positive. Plug in infinity.
Okay, yeah, I can plug in infinity. I know infinity is not an actual number, but that's exactly what I'm going to do. And the cool thing about plugging in infinity is such a giant number that the only things that I really care about are the first 2 terms. Okay, so think about this for a second. If I was going to plug a giant big number into the top, so 5 times infinity to the 4th. Is that going to be a positive or a negative number?
Positive.
Positive. So I'm going to use my sign test again and just see where it's going to. What just happened?
Oh my God. 2 points.
Yeah, that's positive. Okay, if I was going to do the same thing on the bottom and plug in a positive infinity, would I get a positive or a negative? Positive. So where is this function going to as x approaches positive infinity? It's going to infinity. Okay, so that sign test is super valuable. It makes things so much easier. What's that? Well, it has a positive slope. So you can actually find the equation of the slant asymptote by doing long division. Yeah, exactly. Okay, number 12. Number 12 is not written in standard form, so we got to think about, if I FOIL this out, I'm only thinking about the first term. What would the first term on the top turn into?
2x squared.
Careful.
No, it's more than that.
2x.
2x.
What? Cubed. 2x cubed. There's 3 x's on the top. What about on the bottom? Be very careful. If I was going to FOIL it all out, what would the first term be? No. Okay, notice that the 3 is being squared also. So it's going to be 9x cubed. If I FOIL that all out, I have to do 3x times 3x first. Okay, so now, do I have a horizontal asymptote? Where's my horizontal asymptote? At 2 ninths. So what is my limit value as x approaches infinity? 2 ninths. Okay, so it does say a little note there that helps us figure that one out. Consider the highest degree. The rest of them just don't matter. They're insignificant as you're going to infinity. All right. Are these the last two? Okay. All right, so there are these rare situations where you have more than one horizontal asymptote. Okay, and they occur when you have square roots. Okay. Yeah, so you have, so it would be like a John Travolta that's like bound by 2 horizontal asymptotes. So the nice thing is that they're super easy to find because you just kind of like simplify in your head. Okay, so remember, I'm just only worried about, gosh darn it, that first term. So if I was kind of just going to consider on the top, if I have a square root of 4x squared and I was going to simplify that, what would that turn into?
4x.
It would turn into a 2x. Okay, so if I kind of think of this as 2x over the bottom, I have a situation of which case? Okay, it's going to be the same, so I have a horizontal asymptote at 2. So this is the same, where it's the same on the top and the bottom, so I'm using the coefficient. I have horizontal asymptotes at y equals 2 and negative 2. Okay, because we took a square root that causes the 2 scenarios. So I know that my answer is either going to be 2 or it's going to be negative 2. So how am I going to decide that as x approaches infinity? Okay, we're going to plug that infinity idea and do a sign test. Okay, so if I was going to plug in a positive infinity into the original, just because of the square root, that's the difference. The square root causes this, like when you take the square root of things, you get a plus or minus, right? So that's why in this situation we have 2 horizontal asymptotes. This function looks like a John Travolta that is like bound between negative 2 and positive 2.
Everything's positive.
Okay, so if I do plug in a positive infinity, we would get a positive over a positive. So where is this function going as x approaches infinity? Positive 2. Remember, our asymptotes are at 2. So this one is going to 2. It's going to positive 2. Okay, so for question number 14, we have the same function, but this time we're going to negative infinity. Where would that one be going? To negative 2.
I'm sorry, Tyler.
Okay. Alright, so you guys have about a half an hour. The nice thing about this one is that those first